In the silent darkness of space, nothing forgives mistakes. One wrong assumption, one untested idea, and entire missions disappear into the void. Tonight, we follow humanity's most powerful survival tool, the scientific method, not as a classroom lesson, but as a lifeline stretched across billions of kilometers. Every hypothesis is a gamble. Every experiment is a message sent into cosmic uncertainty. And somewhere between observation and proof lies a truth that changed how we see the universe forever. This is not just science. This is humanity learning how not to be lost in the dark. And what scientists discovered in the process was never part of the plan. Space science begins with a question that refuses to stay quiet. Why do planets move the way they do? Why does light bend? Why does the universe expand? Scientists do not guess blindly. They observe. They measure. They notice patterns hidden beneath chaos. A distant star flickers differently. A planet drifts slightly off prediction. A signal arrives late. Observation is the first whisper of truth. But observation alone is fragile. It can deceive. In space, distance distorts perception. Instruments become our senses. Telescopes become our eyes. Satellites become our ears. The scientific method begins here, not with certainty, but with doubt powerful enough to demand proof. From observation comes the hypothesis, a bold attempt to explain the unknown. Scientists propose invisible forces, hidden particles, unseen laws shaping reality. But in space science, a hypothesis is never comfort. It is a risk. If gravity behaves differently far from Earth, everything we know could collapse. If radiation acts unpredictably, survival itself is uncertain. Hypotheses are fragile bridges built over infinite darkness. They must be tested, and testing in space is unlike testing anywhere else. There is no repair shop beyond orbit. No second chance on Mars. Every test is performed where failure is permanent. Experiments in space are acts of trust between humanity and the unknown. Instruments are launched into environments never touched before. Sensors measure radiation that could erase memory. Probes sample atmospheres that could destroy metal. Each experiment asks a simple question: does reality behave as expected? Sometimes the answer is yes, but often space answers differently. Data arrives that contradicts predictions. A spacecraft slows when it should accelerate. Light bends more than theory allows. And in those moments, science does not panic. It repeats. It verifies. It tests again. Because truth in space demands relentless confirmation. But then came anomalies. Tiny deviations. Numbers that refuse to behave. A spacecraft traveling beyond the outer planets slowed ever so slightly. Not enough to alarm, but enough to question. The scientific method demanded patience. Scientists examined heat radiation, gravitational pulls, instrument drift. Every possibility tested. Every assumption challenged. The anomaly persisted. Something invisible was influencing motion. Something subtle, persistent, undeniable. The universe was not behaving according to expectation. And that meant one thing: knowledge was incomplete. To test a mystery in space, scientists cannot simply reach out and touch it. They must design experiments that travel where humans cannot. Probes become explorers. Algorithms become investigators. Every measurement is compared, repeated, challenged. This is the core of the scientific method. Not proving yourself right, but attempting to prove yourself wrong. And when every alternative explanation fails, the universe begins to reveal something deeper. The anomaly was not error. It was information. And information changes everything. Then came a realization that transformed curiosity into urgency. If our models of space were incomplete, navigation itself could be uncertain. Missions rely on prediction. Prediction relies on understanding. And understanding relies on the scientific method. Scientists refined equations, redesigned experiments, questioned long-held assumptions. The anomaly forced science forward, not through confidence, but through humility. The universe was teaching humanity how little it truly knew. As experiments multiplied, a pattern emerged. The anomaly appeared where gravity was weakest, where emptiness dominated. The scientific method pushed deeper. What if space itself was not empty? What if unseen energy filled the void? The hypothesis was bold, almost uncomfortable, but science does not reject discomfort. It tests it. Observatories scanned the universe. Measurements expanded, and slowly, a picture formed that no one expected. Evidence accumulated. Independent observations confirmed similar effects across vast distances. The universe was not simply expanding, it was accelerating. Something unseen was pushing galaxies apart. The scientific method had led from observation to hypothesis to testing to evidence to an unsettling conclusion. Space was not silent emptiness. It was active, dynamic, influential, and humanity had been moving through it without knowing. But science demanded more than acceptance. Could this force be measured precisely? Could predictions be verified? New missions launched, new instruments designed. Each experiment refined understanding. The scientific method continued its relentless climb toward truth. And with every confirmation, a deeper realization formed. Humanity had not discovered a new object, but a property of reality itself. The twist was not in what scientists found, but in how they found it. The scientific method did not reveal certainty. It revealed mystery. Every answer uncovered deeper questions. The universe expands faster than expected. Space contains unseen energy. And humanity's greatest discovery was this: knowledge is never final. The method itself is the real achievement. Observation, hypothesis, experiment, evidence, revision. The cycle that prevents us from being lost in cosmic darkness. Space still holds more questions than answers. And that is exactly why the scientific method matters. It is humanity's compass in infinite darkness. Every discovery begins with curiosity and continues with courage to question. If this journey through cosmic uncertainty sparked something inside you, stay curious. Because the next breakthrough could begin with a single question, perhaps yours. The universe is not finished revealing its secrets, and neither are we. Subscribe to keep exploring the unknown, where every answer leads to a deeper mystery.